Hi, in this tutorial, I'm going to introduce explainable machine learning using the IML package. I'm going to focus on the accumulated local effects, which I'm going to call L, A-L-E. So what is L? L is a model agnostic method that infers the relationship between the response variable, in our case, the lane cover class, and the predictor variables, that is the Sentinel-2 bands. Model agnostic refers to methods that can be used to any machine learning method. Okay, so why do we need L? We need L to understand the marginal effects between the lane cover and the Sentinel-2 bands. The marginal effects shows us how a lane cover class changes when the spectral reflectance changes. To learn more about the L and the IML package, please refer to the resources in the links below. I also wrote a book on data-centric explainable machine learning for lane cover classification. You can also check the book in the link below. Okay, so the first lab tutorial consists of the following 6 steps. So step 1, we are going to set up the working environment. In step 2, we will prepare training and test datasets. In step 3, we will perform exploratory data analysis. In step 4, we are going to define model tuning parameters. In step 5, we are going to train and evaluate the random forest model. Finally, in step 6, we are going to compute accumulated local effects. Okay, so we are going to start with step 1, and that is setting up our working environment. So first, we are going to install and load all the necessary packages that we are going to use in this lab. You can use the install.packages in order to install the packages that you want to use. In my case, I've already installed all the packages on my machine. So I'm simply going to use the library function in order to load all the necessary packages that we are going to use in this lab. Okay, so let's just run this chunk of code. We can see that everything is fine. There is no error message. Next, we are going to set up our working directory. Please take note. This is very important because the working directory is where all your datasets are stored. That is the Sentinel-2 imagery and the training datasets. So you need to set up the path leading to your data folder correctly. Otherwise, we are going to receive a lot of error messages. In my case, this is the path to where my data is installed. So my data is installed in this folder called 2020. Okay, so let's run this line of code. Okay, everything seems okay. We didn't get an error message. So next, we are going to create a raster object, which is going to store the Sentinel-2 imagery that we are going to use in this lab. So I'm going to create a raster object, which I've named RVARS, which simply means raster variable. Okay, so I'm going to use this take function in order to load the Sentinel-2 imagery into this raster variable object. Okay, so let's run this line of code. So everything seems okay. And then next, we want to check the attributes of the Sentinel-2 imagery that we have just loaded. So we are going to use the print function. So let's run the line of code. We get an output. Here we can see that our raster object is of class raster stack. It has the following dimensions. We have the number of rows, the number of columns, the total number of pixels, and the total number of bands. In our case, we have only 9 bands, which I've selected from the original Sentinel-2 imagery. And then next, we have the spatial resolution, which is 10 meters by 10 meters. And then next, we have the extent of our raster imagery. Okay, and then next we have the coordinate reference system. Here we have our UTM, Zone 35 South, and the datum is WGS84. And finally, we have the names of our bands. So we have band 2, blue, band 3, green, band 4, red, band 5, 6, and 7. These are the vegetation red edge bands. And then we have band 8, the near infrared, and then band 11, 12, the shortwave infrared bands. Okay, so next, we also want to load the training data points. Note that the training data points contain the sample points which is the length cover classes. So I'm going to create an object which I've named here TA underscore data. This simply means training data. Okay, so I'm going to use the read OGR function in order to load the sample training data points with which are in shapefile format. Okay, so once I've loaded these training data points, I'm going to use the summary function in order to check the attributes of the training data points. So let's run this line of code. Okay, so this is our output. We can see that our training data points has got 1911 features, and this is the information about the data points. So we have the following land cover classes and their corresponding points. Okay, so Bay Areas has 218 points, built up areas has 742 points, cropland has 260 points, grass open areas has got 553 points, water has got 41 points, and finally woodlands has got 97 points. Clearly, our training data set is not balanced. Okay, so we'll talk about this in the later stages of these tutorials. Okay, so next we want to visualize the training data points on the Sentinel-2 imagery. So we are going to use the view RGB function from the map view package in order to display these training data points. Okay, so if I run this line of code, we are going to get this image. Okay, so this is going to show us the training data points. So we can visualize the distribution of the training data points on the satellite imagery, and we can also zoom in and zoom out. We can click on a certain point and then we can see its name. For example, this is woodlands. Okay, we can click on another one, and this is showing us the built up area. Okay, so this is just showing us our training data points on the Sentinel-2 imagery. Okay, so this is all about step 1. Thank you very much for watching this video tutorial. Please subscribe to my channel so that you get notifications when I have another video. See you next in the next tutorial. Bye.